In this tutorial, I'm going to teach you how to read the model summary table used in SPSS regression. As a reminder, I am building a regression model with grades as my dependent variable, what I'm trying to predict and understand, and absences and SAT scores as the independent variables. This is the last video in a 4-video playlist. The first video I showed you how to build the regression equation. The second video is how to read the coefficient table. The third video, how to read the ANOVA table. And this video is how to read the model summary table used in SPSS regression. Besides this, the table, I'm going to show you graphically some information as well, how to read some of this as well, or what it means. So now I'm going to talk about R, and really that's Pearson R and R squared. Now, Pearson R 0.965 squared is equal to the R squared of 0.931. And again, that's just R squared. The actual R squared can be derived from the ANOVA table, which I discussed in the previous video. I take my regression sum of squares divided by my total sum of squares, and lo and behold, this equals 0.931, which is R squared. And what I'm really doing here is this. For R squared, I'm taking the difference between the regression line and the mean divided by the difference in the actual values to the mean. So I have the estimate minus the mean, each estimate minus the mean value, I sum those up and square it, divided by the actual values minus the mean squared. I'd sum up all those. That's what R squared is. Now, back to the table. Adjusted R squared is based upon, it's an adjustment based upon the sample size and the number of regressors. It is pronounced as R bar squared. Knowing the actual equation isn't that important. It's just understanding how it's derived or how it's calculated. It's really kind of complicated. So it's 1 minus 1 minus 0.93 times the sample size minus 1, which is 10 minus 1, divided by 10 minus 3 minus 1, which is, those three are based upon constant absences and SAT scores. And trust me, if you did the math, it would equal to 0.911, which is my adjusted R squared. Again, the actual knowing how to use the equation is not important, just knowing that it's based upon the sample size, an adjustment based upon the sample size and the number of regressors. Now the standard error, the estimate, right there. So I'll go back to my ANOVA table, and I take the mean square of the residuals, take the square root of that, and that is equal to 4.729. This is based upon the residual errors divided by the degrees of freedom. In this case, it's 7. And this is equal to 22.366, if you recall. That's where that number comes from. And I'm just taking the square root of that as well. Visually speaking, I'm taking the actual values, taking those actual values, and I'll plot in my regression line. And these brown dots are my estimated values. And in essence, what I'm looking at is the distance between the actual and the estimated. And that's my residual sum of squares. And that is what I'm trying to get to with my standard error of the estimate. And that has been the model summary. An explanation on how to read that table. Anyway, share the knowledge, share the love, as always. Facebook, Google+, Twitter. Comments, suggestions, and likes. Don't forget to like us and subscribe. And always, remember our motto,